Good morning, everybody. Hopefully, everybody already took exam 2. There's about 4 or 5 that did not get to take it, so I sent you guys who didn't take it an email. Then you have up to to 9 p.m. tonight to finish it. If not, you guys cannot make up the class because I've been telling you about this test for a while, please. Okay? All right, so if you did not take the test, you have till 9 p.m. tonight to finish it. If you don't finish by 9 p.m. tonight, I'm sorry to tell you, I cannot be nicer than this because I gave you 2 days to finish it last week, and I'm extending it today just for you. So if you don't finish it by 9 p.m. tonight, exam 2 grade will be 0, all right? But most of you took the test, and most of you did very well, so I'm proud of you, okay? All right, we're done with the chapter on sets and probability. Now we have 2 chapters left. One of them is very long, which is statistics. We do that at the end. But this chapter now is about exponential functions and logarithmic functions. Okay. So what is an exponential function? It comes from the word exponent. It's anything that where the variable is raised to, where a constant is raised to a variable, like f of x equals a to the x. So examples of exponential functions will be what? F of x equals 2 to the x. F of x equals what? E to the x. Remember, e is not a variable. It's 2.7, whatever we learned before. Or it could be f of x equals 1/2 to the power x. So the base is constant. The only variable is the exponent. So we call that exponential functions. Okay? So what we're going to learn, hopefully everybody has a calculator available. So that way we can learn. So what we're going to learn in this class is we need to graph it so we can understand the behavior of such functions. Okay? All right, so let's start with something easier. Let's say I want to graph f of x equals 2 to the power x. Since I don't know what the graph is going to look like, I make a table. I can call f of x as y. So I'm going to pick some negative numbers for x, and I'll pick 0, and I'll pick some positive numbers. So you notice I pick numbers that are very diversified, some negatives, 0, positives. That way I want to know where the graph looks like. Okay? Now I'm going to go to my calculator. Okay, x is -3. So everywhere I see x, I'm going to put -3. So how do I do 2 to the -3 on the calculator? I do 2, y to the power x, 3 negative, right? And if you do that, you should get 0.125. So I want to wait till see, be sure everybody got that answer here. Did you get 0.125 when you found 2 to the power -3? Are we good?
Yes.
Okay. X is -2. So everywhere I see x, I go -2. So I go to the calculator, 2 to the power x, 2, right? I get 0.25. How's that number to everybody? Are we good?
Yes.
Okay. Now x is 0. X, I put 0. Any number raised to power, -1. X is -1. So I do 2, y to the x -1, 1 and then negative. I get 0.5. So when x is -1, did everybody get 0.5 for y?
Yes.
Okay. Now I need x is 0. Any number raised to power 0 basically is 1. You don't need a calculator for that. Okay. Now x is 1. That's easy. I don't need a calculator. 2 to the power 1 is 2. X is 2. 2 squared is 2 times 2 is 4. X3, 2 to the power 3 is 2 times 2 times 2, and I get 8. So now I'm ready to graph it. This is X and this is Y. The first point is -3 and 0.125. -3, I go left 3. 0.125 is just a little bit higher right there. Then -2, 0.25. -2, I go a little bit higher than this point right there. -1.5, a little higher than this one. 0, 1, 1, 2, 2, 4. So when you graph it, you're going to get a graph that looks like this. That is the graph of y equals 2 to the x. Now let's learn about this graph. What do you notice as x gets bigger? Y also gets what? Bigger. Is if as x gets bigger, y gets bigger, we call that increasing function, which means like has a positive slope. See? What else you notice about this graph? It doesn't touch the x-axis or it doesn't go below. It's all the value of y is always positive, even when x is negative. That's why the graph is on top of the x-axis, because on top of the x-axis, y is positive. And be sure you put the arrow this way and the arrow that way. Why? Because it doesn't mean these are the only points I can pick for this graph, right? I can what? I can basically pick -7, -8, but I don't have time to pick all of that. I just know the pattern. Those points, the pattern is just going to keep going up and up. What else you notice about this graph? At the beginning, it goes up slowly. And after a while, what? It takes off. Like here, for example, if I pick x4, get 16. x5, 32. See? The numbers gets bigger as you go after the 4 here. So this will be the graph of y equals 2 to the power x. So how we're doing so far? Is everybody okay with this graph?
Yes.
Okay. Now, if I ask you, for example, a graph x equals 2 to the power x plus 3, I don't really need to go ahead and make a table here. So what I need to do is 3 is this is 3 right here. And I draw the same graph, I just multiply up by 3. See? This 3 means I pushed up this graph 3 points higher. 1, 2, 3, and then I push the graph. It's the same graph, this plus 3, just like as if you're blowing it up, picking up by 3. And I don't really need to go ahead and make the same table. So once I get one table, I'll get the same thing. So what if I tell you, for example, I want to graph y equals 2 power x minus 3. I go down 3, right? And then I do my graph like this. It's the same graph, it's just you're pushing it up or down. Okay? All right, you can go ahead and copy this class, and I will show you much more examples in a minute here. And as you're copying it, if you have any question, you let me know. Okay?
Okay.
Okay, are you guys done copying it? You sure you write
Uh,
I'm sorry?
here, yeah, question here. What we did, x3, y become 8.
Yeah.
What,
Because
what we
the
did
pattern
there?
is, watch why. How do you go from 1 to 2? Double the 1 is 2, double the 2 is 4, double the 4 is 8, double the 8 is 16. Because every next number is double, so I don't have to go back and substitute it. You understand? So the pattern is every next number is double the previous number. Or you can just replace x with 2, x with 3, 2 to the power 3 is what? 2 times 2 times 2, which is 8. So whichever way you want to do it, it's going to be the same numbers. Do you understand me?
No.
Okay. This now 3. 2 to the power 3. So go to your calculator. 2 to the power 3 means 2 is multiplied by itself 3 times. 2 times 2 is 4 times 2 is 8. X is 4. So you have 2 to the power 4. That means you're going to multiply 2 4 times. 2 times 2, 4 times 2 is 8 times 2 is 16. So you're replacing these numbers in this here, where X is, to find the value of Y. That's where these numbers come from.
Now I got it.
Okay. And then what do you notice? As X gets bigger, Y gets bigger. If that's the case, we call it increasing function. And it makes sense it's increasing because it's like it's taken off.
So
You know
when
what the word increase?
when
Go
we
ahead.
when we write down for x and y, I mean for x numbers, any number we're gonna put, right? But it has to be a negative number at the beginning. Is it
Yeah,
correct?
exactly. Yeah. You don't have to pick -3. You can pick -5, -2. You have to pick different numbers. But you can't just pick all negative. If you pick all negative numbers, you're only going to be graphing this side. You don't know what happens to this side. So the reason I pick some negative, 0, and positive, that way I can cover all parts of the graph.
Can we put positive number and make this arrow to the left?
What do you mean? Well, arrows has to go left or right. You know what the mean arrow to the left means? Means I only picked x -3. Like when x is -10, the points are somewhere there. I don't have time to keep calculating them. The arrow means keeps going forever. Keeps going forever. That's what the arrow means. See, to graph this function, I have to pick actually millions of points, like x -100, -99, negative whatever. But I picked only few, and I connect them. I see, there's a pattern. So I know, what? Most likely it's going to keep going all the way to the left. It's most likely going to keep going to the right. That's why we do it.
So it's mean infinity.
That's correct. When x is
Yeah.
-50, it goes to 0. When x is positive infinity, y goes to positive infinity. Yeah.
But why we can draw the arrow from right side to left?
You doesn't. You mean do this first, then this?
No. Draw for example, arrow you draw from the left to right and on top. Can we do this action from the right side to left side on top?
Like this, you mean?
Right.
Because y is going to be a trillion, right? Y is going to get very large, right? If you put y here, y is very small. See, like 1. But y is going to, after a while, y is going to be like in a trillion after you keep putting on. So y is a trillion means, up there. That's why you don't go here. You have to go up here because y is going to get very large. Y gets large when you go here. If you hear y is small, like y is 1, 2, 3, 4, 5. I need y to be a lot. That's why it has to be over here. Do you understand it now better? This is y. But y is large. Y is large over here, not here. Here, x is large, but y is small. Y is like elevator, like this is y1, y2, y3, y4, y5, y6. See? Okay, does that explain it to you now?
Yes.
Okay, good. All right, can I erase the board now?
Yes.
All right, so let's graph function. I have a calculator already, class. Let's say I want to graph
Oh.
y f of x equals half to the power x. All right. Please mute yourself because we don't want to be loud here, class. Please. All right. If I want to graph this one, I don't like fraction, so I'm gonna rewrite that as instead of 1/2, I'm gonna put 0.5. They are the same because half and 0.5 are the same. Correct? Okay. Now let's make a table. I don't know what this graph is gonna look like, so I'm gonna pick what? I'm gonna put -4 here, right? It doesn't really matter. And then I'm gonna pick 0 and 3 and 4. I don't really have to pick the exact points. As long as I pick some negative number, zeros and positive numbers, I'm okay. You understand that, class? It's up to you as long as you make the points different. Now, I have a calculator. So that everywhere I see x, I need to replace it with -4. So this one, you cannot do it in your head. You have to go to the calculator. So I'm going to go to the calculator. And I'm going to put 0.5. Remember, I taught you in this class how to raise to a power. X to the power y, then 4, then negative, equals. I got 16. I'm going to stop here for a second. Is 0.5 to the power -4, 16 for everybody. Did you get that number?
Yes.
Okay, now what is x now? -3. So everywhere I see x here, I'm going to put -3. So I go to the calculator. I'm going to put 0.5. Remember, you're going to have a calculator to do the homework. Raised to the power -3. I get 8. Did everybody get 8?
Yes.
Now, what is x? 0. So everywhere I see x, I put 0. But any number raised to the power 0 is 1. I don't need a calculator. Even a million to the power 0 is 1. Any number, so you guys need to know that. A number raised to the power 0 is not 0. It's always 1. Now, how much is x? 3. So y will be what? 0.5 raised to the power 3. So I'm going to go to the calculator, 0.5 raised to the power 3, and I got 0.125. Did everybody get that?
Yes.
Now, what is x? 4. So it'll be y, 0.5 raised to the power 4. So let's go to the calculator. I get 0.0625. Did everybody get that, class?
Yes.
What do you notice here? What happens when x gets bigger? Who can tell me what's happening to the y?
Fine.
It gets smaller.
Exactly. So that means it is what? Increasing or decreasing function? It is what?
Decreasing.
Decreasing. Why? Because as x goes up, y is going down. You need to know these terminologies, class, if you're a business major. Okay? So how do we graph it? All right. What do you notice about y value here, everybody? Always positive. Do you agree? That means the graph is going to be where? Only on the top part of the x-axis. Okay, let's graph it. Negative 4, 16. Negative 4, I go left 4, up 16. Negative 3 for x, y is 8. Negative 3, y is 8. 0, 1, 0, 1. 3 and 0.125. 3, maybe right here. 4 is even smaller. So you know what? I know what the graph's going to look like. I don't need it to make any more points. It's going to go like this. And I'm done. And you notice it's decreasing. It doesn't touch the x-axis because y, I don't see y 0 at all. Y is always positive, means the graph is always going to be on top of the x-axis. So what does this function looks like? Look at y, 16, 8, $1. This is as if your dad gave you $16. The first day you spent half of it, $8. Second day you spent half of the 8. So you what? $1, and so on. That's basically what it is. So this is the graph y equals 1/2 to the power x. But if I ask you to graph y f of x equals half to the power x plus 3, so what do? I go 3 here, and then I draw my graph. Why? That means I push this graph 3 units up to the right, up to the, 3 units up. Okay? All right. Now you can go ahead and copy this graph, and then we'll talk about it in a minute. And as you're copying it, if you have any question, you let me know. Okay? Let me know when you guys finish copying it so I can show you another example here, okay? I'm going to give you the rules now in a minute, okay? All right. Is there anybody who's copying? Y'all need more time to copy?
No.
Okay. So here's the rule. Now I showed you your book is not going to go like me, explain to you how you graph it. Your book is going to tell you, write down the rules so you'll be able to do the homework class. Okay? All right. And I'll tell you what it means in a minute. If f of x equals a to the power x, and a is between 0 and 1, then the graph's going to look like this. If f of x equals a to the power x and a is larger than 1, then the graph looks like this. Okay, what does that mean? Give me a number between 0 and like 1/2. So a good example of that, like 1/2 to the power x. Give me a number larger than 1, like 3 to the power x. That's why it's going to look like this. See? So you look at a. If a is between 0 and 1, like what, 1/4, 1/5, 1/6, 1/7, then the graph's going to go down. If a is larger than 1, like what, 2 to the power x, 1.5 to the power x, 9 to the power x, then the graph is going to go what? Oh. Sorry. Go like this. Up. So let's say this was going to happen on your homework. Graph f of x equals 10 to the x. How much is a? 10. Since it's larger than 1, you don't have to graph it at all. The graph's going to look like this. Then they're going to tell you graph f of x equals 1/4 to the power x. A is 1/4. It's between 0 and 1. That means right away the graph like what? Does that make sense? Do you understand what I have summarized for you on the board?
Yes.
Okay, you can go ahead and copy it too, because that's going to help you with your homework. Then I need to show you different kinds of graphs in a minute. Okay.
Hey, Professor, I had a question.
Yes, sir.
So, okay, when you draw the line, how do we know what way the line goes on on the bottom one you did?
But you never touch the x-axis. It gets close to it. Never make it touch the x-axis on all of them.
Yeah, but I'm saying how did you know it go like to the left or right?
It depends on the number. Look at here, 10. That's more than 1. So it goes from left to right.
Okay, cool. I got you. All right.
Number 1/4. It's between 0 and 1. Therefore, it goes like this.
Okay.
Got it?
Yes, sir.
Yeah, that's how your book teaches you. I really don't like this, but I like for you guys to just pick points, okay? But my goal here as a professor here, I want to explain to you why they graph it. I don't like to teach you rules without you guys really convinced why it goes this way, right? That's why I pick points for you guys. Okay? You know, that's how you really learn math, not by rules. You learn math the hard way, the blue collar way. Think of yourself as a construction worker. That's how you learn math. You don't learn math by sitting in the office. Okay, can I erase the board now?
Question here.
Yes, ma'am.
When it's fraction, we have to always make a whole number, right? If we want to make easy.
Yeah, it's better to make it as a decimal. Like 3 over 2, make it 1.5. Divide 3 by 2. It's better when you graph it, yeah. Okay, can I erase the board now?
Yes.
All right, we're gonna now graph 2 more functions. Now remember, guys, have a calculator from now on. From now, all the time, have a calculator ready. The rest of the semester is all calculator work, okay? So don't forget, each lecture, from now on, you're gonna have a calculator ready. And you're gonna need it for also exam number 3, which will be later on. All right, now, let's say I want to graph f of x equals e to the x minus 1. Remember, e is not a variable. Remember, we found e when we learned continuous. We learned 2 things. When we learned the continuous interest, remember compound interest, we said e is on the calculator. You find the letter e. So now you don't know what this graph looks like. So what do? You make a table. X, you can write y or f of x. It doesn't matter. They're the same. I don't know what the graph's going to look like, so I'm going to pick a lot of points here. -4, -3, -2, -1, 0, 1, 2. I can pick as many as I want. Is that okay? All right. Now my goal is to find y. Remember, y is e to the x minus 1, right? What's the first number for x? -4. X equals -4. So I'll be y. E here's x. -4 minus 1 is -5. Now I go to the calculator. I need to find e to the -5. How? Watch me. Here's my calculator. Okay? So e to the -5, I put 5 negative, and then I click e to the x. Wow. Very small number. 0.00673, whatever, lots of numbers here. I'm gonna wait for a second. Did everybody get this number on their calculator? When x is -4.
How e looks like in calculator? E power to the power x? Is it
Exactly.
that one?
Uh-huh. First of all, you put -5, then you click e to the power x. If you got 0.0067, whatever it means, you hit the right key. Did you get that?
No, it says error.
Okay, so why don't you do this?
-5 to the power e.
Okay, relax. I know what you're doing wrong. Just relax. Press 5 first. Did you press 5 first?
Yes.
Then there's a sign plus and negative. Click on that now. The one that says plus negative. Click on that. Did you do that?
I am looking for plus negative.
Okay.
Plus negative.
What kind of calculator do you have?
I don't know. But shall I show you?
Yeah, show me on the.
Yeah.
Okay, okay, let's do this. Clear everything. Press E first. Then press -5, not -5, -5. then hit the equal or enter sign. Does that help you?
No, still doesn't.
Okay, okay. When you press E, do you see, after you press E, do you see something like this shows up, like a little hat, or no?
No, when I press E, it shows IN.
Okay, so do me a favor. Take a picture of it and send it to me and I'll help you individually. I don't want to. Okay, take a picture of your brand name of your calculator and text it to me, and I'll talk to you later about it. Okay. All right. Now,
Okay.
okay, I'll help you later because we need to get going here. X is -3 now. So I go to X. Everywhere I see, I put -3. -3 minus 1 is -4. So I go to the calculator, and I'm going to do -4E, and I get 0.0183. Okay. Is everybody okay how I got that answer? Okay. Now what? Now you can guys play with this at home afterwards. When you copy this table, then you practice when you go to Google. Says how do I find E on this brand of calculator? It'll teach you class. Okay. All right. Now X is -2. Here's X -2. So I need to find E to the -3. E to the -3. 0.049. X is -1. 0.3. X is 0. E is X0, sending E to the -1. So I go -1, E, 0.3678. This is second here. Oh, I made a mistake here. X is -1. -1 minus 1 is -2. I need to find E to the -2. 0.135. Now X is 0. E, I need to find E to the -1. 0.3678. X is 1. 1 minus 1 is 0. E to the 0 is 1. X is 2. 2 minus 1 is 1. I get 2.71. X is 3. 3. E to 3 minus 1 is 2. So if I need to find E squared, 7.38. Now look here. You really don't need to graph the whole thing here. You don't need to plot the points. What happens as X goes up? Who can tell me what happens to the Y? Does Y go up or go down? As X goes up,
It
goes up.
goes
That
up.
means you have increasing function. You don't really need to graph it. What does increasing function look like? Watch this. When X is what? 0, Y 0.06. Increasing function looks like this. And you're done. You don't have to plot the points. All you need to know if it's increasing or decreasing. It's above the x-axis Y. I don't see a single negative or 0 number for Y. But when X is 0, Y was not 1, was a little lower. It's a little lower than the normal graph that we did. So all you got to do here is just see when X is 0, how much is Y, and then just draw as an increasing function. If these numbers go down, then you draw the graph like this, but it doesn't go below the x-axis, okay? But it's very important to copy these points. Why? That way you can go and practice at home, and if you see if you get those numbers, okay? It's not that difficult. You just go to Google and put the brand name of your calculator. Says, how do I find E on and you put the brand name of your calculator and it'll teach you how. Okay? All right, go ahead and copy class, and then I'll show you one more in a minute. Okay? If you have any question, let me know.
The only thing I'm talking about, whenever I did the first one, when I put in -4, it didn't give me 0.00673.
Because you have to put -5. So next
Yeah,
is negative
I put in -5. I did Shift E. Let me start it over. I did
Okay.
Shift E and then.
You don't put Shift E. It's just Shift LN gives you E.
Oh yeah, it's just Shift LN then.
Yeah. Huh?
Okay.
And what did you get?
Just LN, and then I put in as a -5.
Uh-huh.
And it gave me 6.739, but I didn't get 0.
Oh, it doesn't give you E on the right side. 6.73 E, something on the far right. Maybe that gives you E -4 or E -5. Far
Yeah,
right.
it gave me the 6.7, all those numbers, and it has, look, I guess this is times 10 -3.
Very good. That -3 means that answer. Move the decimals 3 places to the left, and you get this number.
Okay. Okay.
That means your calculator is programmed on scientific notation. Just move that decimal 3 places to the left, and you'll be in business.
Okay.
Got it?
Got it.
Or you can just divide that number by 1,000, the one you get, and then you get the same answer. All right, let me know when you guys are ready. I need to show you one more graph so you guys are really alert how to do it, so you should be in business. So how we're doing so far? Everybody doing good?
Yes.
Okay. Let me know when you're done copying it so I can show you another graph here. Let me know when everybody's done copying. Does anybody still need the board? Who still needs the board?
I guess we're done.
All right, so let's grab another one.
How much though? Yeah.
You guys need this for your business major. You're going to be graphing so many graphs. You need to understand increasing, decreasing, like the demand and the supply. Demand is increasing or demand is decreasing. So you need to know how to graph. So let's say I want to graph e to the negative x plus 1. Okay? So I don't know what the graph is going to look like. So I'm going to make a table. I'm going to pick some negative numbers, 0, and positive numbers. Right? Okay, I'm going to do 1, then I want to calculate. X is -3. So what does that mean? Everywhere I see X, I'm going to put -3. See, there's negative and X is negative. 2 negatives in a row makes it what? Positive. So on the calculator, I need to find e to the 4. So I'm going to go to my calculator. 4 e to the x. Wow, I get 54.59. So what I want you to do here, see if you can finish the rest for me. And I'm going to give you 5 minutes or so. Then when everybody's done, I will put the answers on the board, see if you got it right. So your goal is now, for example, x is -2. So you're going to go to y. Everywhere you see x, you're going to put -2. Double negative, so that means there'll be 3. Then you go to the calculator and you put e to the 3 and you put the answer in. And you keep going and find me all the y values. I'll give you enough time to practice. And then when everybody's done, I will put those numbers on the board, see if you got them right. Okay? And then we'll graph it together. Okay, let's see if you got it right. So we're going to find e to the 3. 3, e to the x, 20.08. How we're doing?
Okay.
Good? Are we good?
Yes.
Yes.
Okay, now x is -1. E double negative becomes positive. That means I have to find e squared. So I got to do 2 e to the x, 7.38. How we're doing? Did everybody get 7.38?
Yeah.
And now what is x? 0. So y will be e to the negative 0 plus 1. There's no such thing as negative 0, 0. So e to the negative 0 is the same thing as e to the 1. So when I do e to the 1, 2.718. How we're doing? Now x is 1. Negative 1 plus 1 is 0. Any number raised to the power 0 is 1. X is 2. So it'll be y. E to the negative 2 plus 1, which is e to the negative 1. So I'm going to do 1, negative, then e, 0.36. Now, the last one is x is 3. Y will be what? E to the negative 3 plus 1. Negative 3 plus 1 is negative 2. So how much is e to the negative 2? 0.135. Now you're ready. What happens when x goes up, class? What's happening to the y?
Decreasing.
Who can tell me? So that means that increasing or decreasing function?
Decreasing.
Decreasing. When x is 0, what is y? 2.7. 2.7 is a little high here, right? What does decreasing mean? It's going down. This. Let me do it better here. This will be the graph right here, class. It's going down y, and I'm going to call it decreasing function. Because as x goes up, y goes down. So all you really need to do, you don't need to plot every single point. All you need to know if it's increasing or decreasing. If it's decreasing, goes psh. Increasing goes the other way. And that will be the answer. You guys can copy it, and then I'll be waiting for your questions.
All up in the ooh.
How's everybody doing? Good? All right. And that basically, this is where I really want you all. Now, on Wednesday, we're going to learn how to do word problems on exponential functions. And then we're going to learn the starting thing on how do we find the logarithms. So you really need to have a calculator handy. Okay? And then next week, we'll finish the chapter on logarithmic and exponential functions. And then we should be in business. But those of you who got here late, there's about 6 out of 31 students in this class did not take exam 2. I emailed the one who did not take it. So I'm giving you till tonight, 9 p.m. If you don't take the test tonight by 9 p.m., your grade remains 0 on exam 2 because I gave you 2 days last week. And I cannot really be nicer than this anymore, class. No, most professors will just make you flunk, period, all right? So if you did not take the test last week, today is your last chance. How do you know you didn't take the test? You know it yourself, and then if you go to campus, you're going to find a 0 on your grade. Okay? Did anybody, who did not take the test? The one that are in the right. Who did not take the test? Did everybody take it that's present today?
I took the test, but not the
I took mine this
pre-exam.
morning.
Okay, all right, okay, good. The ones, did you get my, okay, all right. As long as you, so, has anybody not taken it yet? I don't care if you took it this morning or not. Who has not taken it, period? Yeah, that's good. That means everybody took it already. All right. All right, the ones that I email them, and if they don't respond by tonight, I'm sorry, guys. I cannot be nicer than this here. All right. We got to move on here. Okay. All right. Once you copy this class, this is the perfect place to stop for exponential function. I don't want to start word problems today to confuse you. I'll start that on Wednesday. You guys have a good day. And looking at your grades on exam 2, most of you did very well. I'm proud of you. Just keep up the good work. Right? Okay. Have a good day, everybody. Leave here open so you guys can copy it.